Hi everyone. I'm very happy to be here at droidCon UK with you today. And I think there is lots of people for a talk about dependency injection. It's quite cool. I'm Arnaud Giuliani. As you may hear, I'm French. I'm working remotely for a UK company called Curve, and we will talk about Koin today. Just one word about Koin, about Curve. If you want to join the team and work with Koin, coroutines, Kotlin, cool stuff, there is a link here, and yeah, feel free to join. But let's talk seriously today, and let's take a first embarrassing question: is why? Why, guy, are you crazy enough to try to make another things like that? And yeah, why? And to give you an answer, I will have to come back to 2016. And in 2016, if you remember, in February, we have something like that, Kotlin 1.0, and it was production ready. And because it was production ready, I was clearly waiting for that to be stable. I put it everywhere in all the Android application I could. You could ask my ex-colleague in the moment, but yeah, I put it everywhere. And when you begin to work with Kotlin, you have clearly superhero power. But yeah, we still have lots of tools, and the ecosystem is really heavily Java-based. Not that it's really bad stuff or bad feature. This is really good feature that build up the JVM tools, the JVM ecosystem until now, but with the new syntax and the new language beginning to be kind of boring, and yeah. How we can do something else than having annotation, code processing, generating, how we can do something else. And even in 2019, you can still have lots of articles that says, okay, yeah, with Kotlin, you can have really interesting way to not use any kind of DI framework. That means you have objects, you have functions, you have generics, you have lazy delegates. You can write fun things out of that. But with the time, it's really a bit weird to keep that every day for you. And I was looking for something really simple in terms of DI, Kotlin and Android. Simple because for me, this is the key of writing really efficient application. And when I looked at the market, I was clearly, not finding what I was looking for. And clearly, I want something that is focused on my needs, and I don't want to read heavy documentation. I just want to copy-paste the first Stack Overflow code or first snippet I can find on the website, and I don't want to have to study the theory of dependency injection to be able to use this. Then I want something really simple to read and understand, and also something really simple to write. And this is the main idea, is that if I just put things and if I can't rewrite things just by reading them and say, yeah, I won't be able to use that too much. Or you need an expert in your team to keep that guy as long as possible. To show you all of this, let's take coffee app stuff. Every developer needs coffee all the day then. Something that you usually have to worry about, and let's make an app for that. And this app, I think some of you have perhaps met this app as is one of the Dagger's Summer app. And what we will see together is that we will see just a pure Kotlin version of that app, okay? Nothing amazing, nothing strange, just pure Kotlin interface class, and that's it. And we just start with the first class, that is coffee maker, okay? Just one coffee maker, and we just want to brew the coffee. And after that, we need something to pump the water. We have an implementation here, and just something that is pumping here. And we have something to heat the water, okay? And you see that the last interface is the most complex stuff that you have to see here. And here, this is the exercise, how we do dependency injection. Dependency injection is the exercise to say, okay, I have a coffee maker class that is using two other components by the interface, okay? Because we don't want to use direct implementation of those components, we want to use those abstraction directly. And to make it more complex, the thermosiphon stuff is using the heater to know where it can pump the water, okay? And this is it, you have it. Let's see the code in detail here, and let's begin with the heater. The heater, as you have seen, it's only 3 functions. On, off, is hot. Yeah, not that bad. And then, how we can write it only in pure Kotlin, okay? In pure Kotlin, we have just this class, this electric heater class that is extending heater. And what we are doing is just on, we will just put the heating variable at true, printing some really shiny SQR, putting on false, it is not hotting it, and then we can say if the water is hot. And then, the pumping part, then we need a pump. Yeah, really simple. And what we have here is that we have a class, thermosiphon, okay, really simple, extending pump interface. And we are using constructor injection. That means by constructor, we use the property Kotlin here, the heater, okay? And we will use it in the pump function here to say, okay, if the water is hot, I can pump heat. And we can print the shiny ASCII art stuff. Let's continue, and the coffee maker part here, the last class that is using the 2 others, is not that much complex also, as we have a class, coffee maker, that is using 2 components, then pump and the heater, and then we still use the constructor injection, the pure Kotlin stuff here. And we use it in the brew function that is making heater. We put the heater on, we can take the water, and then we can say, yeah, I have my coffee. And then we put it off to not keep it heated. We need something else, because then this is only 3 classes, and just, yeah, they know they are using, but you need to bootstrap it somewhere. You need to run it somewhere. Then we need an app. Here we have a class, coffee app, okay, why not? We have a property here, coffee maker. Then we need to retrieve our coffee maker instance here. And then we have just a run function just to run the stuff. You may say here, yeah, but it's not really compiling this stuff. Yeah, you're right. And we'll come back on that after that. We will see how I can manage to fill my coffee maker instance here. And this is the question, how we assemble it. And to assemble it, I mean how we can refer to an external system, an external library that help you inject and retrieve components for you, okay? Let's continue. Then how we can imagine this assembling stuff. Then we have the 3 classes without the body here. We just have the 3 classes, and what we could write is that, yeah, we could write it by hand, just very easy. We could say, okay, we have a heater, we have a pump, okay, let's use the heater here, and we have a coffee maker, heater, pump, okay. Super, super, super complex, but the idea is say, okay, if I want to bootstrap this, I want to get the instance from somewhere, then I could ask an injector to have the reference of the class that I'm looking for. It is the coffee maker class, okay? But we are in Kotlin. I could ask Kotlin to say, hey, it's not a class parameter, but it's a reified type here. I just pass the type parameter as a here behind the get, but you can also write it like that. That means that here, injector has the information about the type that you are looking for directly. And also, we could use directly something that is a lazy delegate. That means that this expression is not yet evaluated until you are using it directly. That means that, yeah, coffee maker can be retrieved here, but I don't know yet the evaluation of this. Okay, then for my injector stuff, I imagine that bootstrapping the instance is behind my get stuff. This says, okay, manage to build my electric heater, to build my thermosiphon, to build my coffee maker. I don't want to care about that, okay? And finally, the idea about such simple writing is that we have definitions here, okay? The class definition. We could have something providing a function, because when I'm building an instance, finally it's just calling a function that is, calling constructor of this stuff. And what I need somewhere is a link between my functions to say, when I am this instance, I need this other instance, could you please retrieve it for me? And this is the idea of Koin. Giving in a DSL, a very simple DSL, to say, okay, you just give functions to build your stuff, and it will resolve by yourself, and it's pure Kotlin definition. Okay, let's dive into Koin a bit more, and then what is Koin then? It's an intuitive DSL, it's a lightweight container, and don't be scary. Container, think more about something like just running the functions, pure functions for you. And we need just to run functions to grab instance and make it for you. And we need just a simple API, simple something that you can use it without understanding dozens of pages of documentations. And everything is pure Kotlin, no generation, no introspection or reflection here. This is clearly the challenge of Koin in 2017 when I launched the idea. And if you want to use Koin, you can use Koin just in the core feature. That means it's completely standalone, and you can bring it everywhere in any kind of Kotlin ecosystem stuff. And here you can just use the DI part, okay? What we need to do here is that we need to say to Koin, here's my components, is how I would like to write them. After that, get the things I want here. We need to declare a module, okay? A module is a space where you have definitions, and a definition is just a keyword here that is single or factory. Singleton. Factory, something that is recreated each time you want it. And here, you see that we have a lambda. Then I open a module section. I write single or factory for my stuff I want to create. One instance or every instance I want to create. And after that, I'm clearly free to write anything. It's pure Kotlin. This is your code. And then that's it. 3 keywords. You can describe what you want in terms of application here. Let's go back to those 3 classes about the coffee maker and how we would write it. Let's write a coffee maker module. And okay, let's take the first component and say, okay, we need to declare the electric heater. Okay, single electric heater. Yeah, not that bad. And here, the challenge of Koin is not to reinvent code generation, reinvent introspection that is really slow on Android devices. Then the idea is to say, okay, we have to be explicit. If you need a type, if you need to look at the heater type directly, say it to the reify type here to say single the heater. I want to look at heater in the system, not electric heater. I don't want to expose the implementation. Then I just say, okay, I have a singleton of heater, type heater, and this implementation is electric heater. Let's go to the thermosiphon here. Okay, we say same. We have an instance of thermosiphon. We just say, okay, we need a pump, and we have a compiler error here. Because this is just pure Kotlin inside your code. And we need something. Last keyword that you need, the first one, get. And you say, okay, I just get a heater here. And because Kotlin is smart enough to guess about the type you need here, you don't have to pass the type, and that's it. And this is mainly the form that you have to fill about dependency injection here how to describe stuff that are linked together. And that's it. How you finally write coffee maker, you suggest, oh, okay, we need a coffee maker. We need 2 things to say, to link. Okay, that's it. And yeah, 3 lines, 1 module. I've done that. We can also split it like that. That means that Koin is pure runtime. That means that you don't have proper verification inside your code. But we have tools to help you understand how your graph and definitions can be built, or if there are any problem in terms of building. The DSL is clearly following you in terms of code. Then when you refactor something, when you rename a class, this is in your stuff. This is inside your code. Then it follows naturally your application. And then if you want to split stuff, you just split modules, and then you bring everything in Koin, and yeah, you shake, and then you have dependency injection. Here we just have to talk about a very important concept about Koin, is that once you have declared components somewhere, you have to bootstrap them. And here we have a concept that is a Koin component. A Koin component is a class that is allowed to use the Koin container. And why? Because we want first an interface marker for the stuff. Why? Because we don't want some wild extension everywhere for you. We want to clearly help you understand that you are linking yourself. When you are using this kind of component, you are linking yourself to Koin. And then when you need to restart things like in unit test or any kind of integration test or partly app, let's say headless app, you need the Koin container to do that. Then it helps you identify that your class is linked to the Koin API. But for us, it's clearly the way that help us to give you the Kotlin extensions that are needed here. Inject and get, okay? This is the magical mechanism for that. And then this is also the way for us to bootstrap any kind of runtime. That means that we can bring this to, of course, Android, but Ktor, also multi-platform and stuff. We bring everything out of the box by extensions. They mean that we bring new functions that you don't have because of the powers of Kotlin to bring new stuff here. And how it works, okay? We have here this class that need to bootstrap the instance of Coffee Maker. What do you need here? If you use Koin core here, dependency, you just use the Koin component interface, and yeah, you have it. You can just use by inject, and you have your instance. That's it. Fine. There is a missing stuff here about the Coffee app, is that, yeah, we need to run the Koin container. We need to run Koin and just read your definitions before you can get it, because else, yeah, you won't have your definitions. And in your main entry point, what you have to do is to say, okay, at somewhere, I need start Koin. It's a little DSL to explain how you want to bootstrap and run the stuff. Is there here? You can say start Koin, use the DSL, and the only thing that at least you have to do is to say, I have those modules, and that's it. Once you have that, and if you have several modules, you can just pick them, etc., etc. Once you have that, you can run your instance, and then the container is ready to go, and then you have your coffee. Great. For people that have already done the exercise on Dagger's side, we have something here. We have a lazy link, which is kind of interesting because we mainly rely on Kotlin, and then if we want that kind of link, we can say, okay, we just use Kotlin lazy delegate stuff here. And naturally, we will use the Kotlin power language, the power of Kotlin language to help us delegate the lazy expression here, okay? The idea of Koin is not to reinvent wheel as much as we can. We just reuse what we can there, okay? And then here we just have a delegate to just say, okay, once we want to use the header, I mean at the first line of the brew function, we get the instance here. And it's a Kotlin type, full Kotlin type. Okay, let's go back to what you would have if you have the Dagger exercise, okay? Just to remind that, yeah, you will have to, if you just reopen the GitHub repository, you have all this stuff to say, add provides, add singleton, add modules to say, I have this singleton, I'm linking to this module, I have this module that binds this stuff, and yeah, this singleton stuff, okay. And don't forget to inject constructor everywhere you have. And also here, it's not a lazy Kotlin type, okay? This is Dagger stuff that you have to use here. Okay, not that bad, but I was in the position to say, no, I wanna write something else, and here, it was clearly my position, and yeah, about that. And how you have Dagger is, how do I wanna migrate from Dagger and try to get things out of Dagger and try to have fun with Koin. The idea is to say, okay, we have a graph dependency that is entirely declared in Dagger. What I want to do is to say, okay, I have one of the lowest objects that can be extracted to the other world, to Koin, and after that, I will make a bridge between Dagger and Koin easily, and after that, I will disconnect my graph directly, one by one. And how I can do that? The first thing is I will write my module saying I need a single TOF of electric heater. And in my current code, I will just disconnect the part that is using this code to use directly a property for the Koin component, okay? I can't use it by constructor because Koin don't understand what instance I have to inject by constructor. I don't have this thermos hyphen declared in Koin, then I can't inject by constructor. But I can retrieve it manually with the Koin component concept. And the same in the coffee maker, I will extract the heater of here to say, okay, let's use a Koin component and use it by inject, okay. And this is how manually you can disconnect graph, disconnect things, and pass an application. You can't pass in one time. You have to test portion of graph, portion of stuff you want to migrate if you want to migrate from Dagger to Koin, and if you have any pain with Dagger, of course. If you don't have any pain with Dagger, just stay with Dagger. It's okay, and try Koin in your next application when you want. And the thing is, one by one, we will convert completely the application from Dagger to Koin, and we will have everything in Koin. Like you were migrating your Java application to Kotlin, it's kind of the same here, having something that you can make the run both together. If you want to take a look at an article that we have on the Medium of the Koin project, we have here a detailed article about how we make the migration and how we finally migrate stuff one by one. Okay, let's go with what Koin gives in terms of Android stuff. And yeah, just the first thing is that everyone in the room knows that you can't directly instantiate activity. Fragment is beginning to be more easier, but yeah, we have to deal with this activity stuff that is the hell diagram that every new Android developer has to learn and understand. Then what brings Koin is that Koin brings extension for Android for your activity fragment service and make them as Koin component directly out of the box. And this is really important because then what you just need for your application is you just add this Gradle dependency definition here. Don't forget to run in your main application entry point to start Koin with your definitions. Add an Android logger if you want to see stuff. And don't forget to have the Android context here. And in an activity, just a normal activity, here an app compat activity, you just describe your property like that, val, coffee maker, and you can say just by inject. You have nothing to do, nothing to set up more than just your entry point and your DSL module, and then you are ready to use your stuff here. And that's it. And how you could retrieve your Android context, because sometimes we need. I really discourage you to try to make applications and depends on the Android context because you are linking yourself to the Android context. And I try to minimize this, but sometimes you need, like when you are building a component like Firebase and stuff, you need the Android context somewhere. Then it's this Android context line in the start Koin DSL declaration This one is critical because this is where you say, here is my context for the Android context. And in my DSL, if I have a component like this one, my component here, that is using in constructor the context, then how I do that? I just say, yeah, Android context. It's Android functions to help you retrieve the Android context directly, or you can even write this. Yeah, magic. The previous form is clearly when you want to use an expression directly with the Android context stuff. Here, we just say to Koin, yeah, retrieve me whatever instance you have for this type. How we could deal with kind of transient component like presenters, MVP stuff, some kind of component that follow your activity and fragments. And the easiest way to do that is, for example, to use directly, if I have a presenter that is using my coffee maker instance here, the easiest way to do that is to say, yeah, I want a factory. Because the factory will be asked just the first time you are creating your activity, and then you have an instance here, and then when the activity drops, your instance drops with it. And naturally, we are just giving you an instance each time you need an instance for this presenter and activity. And then in the activity, what you just have to say is just say, I have my presenter, and say, yeah, by inject. And that's it. You just have your lazy delegate stuff here. What was really cool in 2017 is that also Koin has been quickly ready for the Android architecture components. And which is really cool to unlock is that you just need this Koin Android view model line of dependency to write in your Gradle. And we unlock Koin extensions for Android view model. What does it mean? It means that I can write a view model class directly with a constructor here. I can inject my constructor property here directly, which is very cool and straightforward. When I open a module here, I can say, okay, let's describe a view model instance. You see here that it's not single or factory. It's a special keyword because it's a special factory instance that we have to give to the Android system. For Koin, it's an instance that we give, but after that, for Android, it will keep the instance for you and follow the lifecycle for you, all the magical view model lifecycle stuff. And then what we need here is that we say view model of my instance of view model, and it just retrieve the stuff I need here, and that's it. And to use it in any activity or fragment, what I have to use is not by inject, but by view model. Because by view model, I will retrieve the special instance of view model here. And this is the only stuff that you have to keep in mind. This is the only difference with the standard keyword here, is that if you use view model directly, you can use the constructor injection and say, okay, in one line, I have my value here injected. You can use it in fragment. That means that here, you have one instance of view model for your fragment, and you can also easily share a view model instance for your fragment and activity just by one line here. And this kind of expression is really interesting because you can have activity, multiple fragments, sharing stuff, all with the same view model instance, and then goodbye to any kind of complex integration between presenter that have to ping pong each other to say, okay, I'm this presenter instance and I call the activity back. No, no, no. You can just use a view model instance for all your street stuff here. Then, which is very, very interesting. And that's it, yeah. With that, I think you can be very happy to build up your application in Android. What is also very important to keep in mind is that you need to test, and you need to test. We have a bunch of tools to help you test all your declaration and stuff, and the first one that you have to keep in mind is that check your modules and check your dependency graph. The first stuff we have to declare is that how you can verify your Koin dependency graph is just one JUnit stuff here. You just start a JUnit, just start your modules, start Koin, and you just use the check modules functions here that will verify that all your definitions are binding and are okay with that. This is pretty important. The other things that you can use directly is that you can mock other definitions without having to replace stuff. We can offer you a way to mock directly on the fly. Like for example, here, first, I can just use a unit, say I want to start my Koin application. I just use a Koin test interface that is an extension of Koin component, but it's just to say that it brings you the possibility to retrieve your instance in your test class, which is already something very cool. And after that, you can say on the fly, I can mock that stuff. I can mock my iter instance, and I can play with it as it was mocked directly by Mockito. And here you can verify it directly. Fine. This is really the most simple tools that you have to keep in mind about your stuff. Not really forced to use the Mockito stuff, but at least you can retrieve easily your Koin instance directly out of the box. And as you were mainly in a position to write mostly dependency injection by constructor, you don't depend 80% of the time on Koin. Here, I would like to talk about the 2.0 that has been published this year in June. And then since the first version, what has been very cool and followed by people, and Christina was talking about feedback, and the main feedback was, yeah, people like a simple DSL that with 4 keywords you just can write mostly of what you need. And it's really important for the philosophy of Koin to keep simple as possible. The other stuff is to be pragmatic as much as possible also, and in only just a few key of APIs, you can do what you want here. We have a bunch of benchmark here, is that in the 2.0, in 1.0, the Koin version of 1.0, we have some kind of performance problem, and we get rid of that directly with the new 2.0 that bring clearly new extensions, new rewrite about the internals, and I would like just to compare stuff here. I mean, I would like just to compare how I would like to run the Koin version vs the Dagger version of the Coffee Maker app, and just to compare exactly the benchmark of execution. And finally, in Koin 2.0, we are not far away. A part of the startup where, yeah, magically, Koin has to read your stuff before starting, and this is the main point that, yeah, has to scale. For the other stuff, we can retrieve as fast as Dagger for your instance. And when you have to load lots of definitions, you see that it's not so heavy to load at start. And you can even split the stuff if you need, if you really have pain about starting stuff. Here you have a bunch of repository about dependency injection, performance benchmark, comparison stuff. And also, if you have missed it, you have also the changelog about Koin 2.0. You can still have it with bit.ly ready for Koin. I would like just to share more stuff about Koin, but I don't have time. Then I have to select some stuff. Then, yeah, let's talk quickly about the container DSL. And first stuff that if you try to throw away at that on Twitter or any kind of social network, yeah, internet get fired with that. You say, dependency injection, service locator, Koin, yeah, get explode. And finally, I would say that we can say that we use the both patterns. Both patterns because when you just describe your stuff here, you are using constructor injection, your class are not depending at all from Koin, and then instances are created by the container, and you benefit also about the functional DSL with the function stuff here. This is dependency injection. But when your host class is not created by Koin and you have to actively retrieve your instance by hand, here we talk about service locator, okay? And I would say that just, yeah, 80% of the Koin usage will be the description of your components. 20% will be around the platform stuff. Then, yeah, limit as much as possible your usage about the Koin API, but you can declare as much as you want things around your DSL. And yeah, after that, I'm not here to impose any stuff, naming and standard stuff. Call it what you want. I just want to keep this quote about Martin Fowler about, the founding article about dependency injection. And he says, what matters the most is clearly not the pattern, but more how you make the configuration of this. It's clearly important that you separate configuration of usage, okay? Let's go quickly about the functional dependency injection, why we call it functional. It's because when you write your stuff, we are taking care about functions and container. And when you write it, we have something like that, kind of complex expression that says, okay, definitions is a matter of scope, just your bunch of instance, definitions parameter, and we create instance with that, okay? And that just means that when you write things, you unlock your word about expressivity with parameters, DSL extensions, everything in the space. And about parameters, something that's cool that you can do quickly is that you say, for example, instead of having to say set ID to your presenter and say, okay, you have to call it, you can directly pass the ID by parameter injection. You say by this functional approach here, you can write it like that, and I can use it directly, the idea. Cool, I can pass directly object instance directly in my functions declaration. And how I do that is that in my activity, I have my by inject expression here. What I have to do here, it says, okay, I open a lambda to say I can do something by my injection stuff. I say I have some parameters. We use the parameters of function here, and we pass the stuff that we need here. And just pass a string, 42 here, and I have it. And you have the same for all the kind of definitions here. You have the same for the view model. And the view model, you can say, okay, I have an idea in my view model. I don't want to set it. It's clearly just set it with my ID. Then I can pass my ID like that. And why I'm using brackets, it's because it's kind of exploded expression in Kotlin. But keep in mind that just if you want to pass parameter, just don't forget the parenthesis stuff. And in my view model instance, I have it like that. In my activity, in my by view model inject feature, I would say, open me to this parameter, and I send my parameter back to my feature. Great. We could, in terms of container, we could have tried to use the declaration with reflection and try to say, this kind of get everywhere is kind of very heavy. And when you see people that have a constructor with more than 5 or 6 properties, say, are you sure you need all of that? Are you sure about that? But then, if you want to make reflection, you have to forget about the functional dependency injection stuff. We have a sub-project that bring experimental stuff for that and bring extension stuff for the core component of Koin. And then, for example, for the main DSL that we write for the coffee maker app that we have here, we would have written like that. That means that there is no magic. I have to guess what is the constructor of the given instance type that you have here. And then this is not free work. I have to do this for you. And then I would say that for all the JVM stuff like Cater, Tornado FX, and other stuff that just run on desktop, laptop stuff, it's not a problem, servers, etc. For Android, you can unlock them for all the Android stuff, and then more for the view model. That means that your view model that you are declaring in, you can declare it like that. Yeah, that's pretty cool, but be careful to follow your ProGuard rules, and also check that in terms of performance, you will be 4 times to 10 times slower than the DSL declaration. Take in mind. I would like to speak about dynamic module architecture, which is very easy to set up, and this is things that we are making at Curve currently. And what is it is that, for example, you have a container, you can load at start to load dynamically stuff on the flow with Koin. You say, okay, I have these definitions here, and you can unload definitions and instance on the fly too. which is really interesting is because, for example, if we break our applications into onboarding, into wallet, into card management, into transactions, into, profile stuff, many feature, I can say, okay, I can unload this because we don't need that anymore for the user. And also we can replace that on the fly and say, if we do A/B testing, we can just load some bunch of modules directly on the fly, and we can add a new one, like payments and profile, etc., etc. It's really interesting because it allows you to dynamically reload, unload, and load definitions, change implementation on the fly. And also, if you have something that is really hard to describe, like I have things that has to leave for a given time, it will be easier to say, okay, I load and unload this bunch of components, and I have something that is more complex to describe for Scope API. Scope API, for people that are interested, is something that you can say, okay, this is a bunch of definition where they can live for a certain time, and I want to drop them. But it's very more specific in terms of DSL. In terms of dynamic modules architecture, it's not really free like that. You have to be prepared, and you have to write kind of registry plugin architecture because you have to know what modules you load, what modules you want to load, etc., etc. But mostly, in terms of patterns, you can follow the patterns that Google says tell about modularization, about application, etc. But the best thing we'll have to follow about navigation, how you pass feature, etc., etc. But just by loading and unloading your Koin applications, that's really easy to have modules, load them when you want, and then after that you have what you need then. I think it will be a good dive in deeper topic for that. I will have another talk about that. For people who didn't use a Koin before, there is some tip and practice, and also you can go on the website, and there is a getting started project when you can use directly sample project that just only take 5 minutes to test. You can have the quick reference. You can also, my first advice is set up step by step this framework. Don't make it complex at the beginning. Just keep it really simple. And don't forget to check your modules. One of the best feedback about that is that people say that finally, Koin allow me to understand my design, to be free, and to clearly think about my components. Don't abuse about complexity in the configuration files, and also, simplicity, I think, is the key idea of Koin. And try to not put Koin component interface everywhere, then you will link too much yourself to the Koin application. And if you have any question, look around there. There is always someone to answer you, to help you. Also, we are on the Kotlin Slack. You have the Koin channel. You can follow the project on Twitter and Medium. And the most important thing is that we need your feedback. I mean, this project can't be there if there is no 2 years of feedback of people and hundreds and of people. And here you have most of the contributors of the project. I want to thank you. Make thanks for them. And I think this is it for me today. What you have to keep in mind is that Koin is in 2.0.1. We have an unstable version that is 2.1.0 alpha 1. And if you want just to make dependency injection in a Kotlin app, you just Koin Core, Koin Android if you want to just use the basic Android stuff, Koin Scope and Koin View Model if you want to use these feature specific, and don't forget the Koin test stuff. What's next then? In 2.1 and 3.0, we are working heavily. All the contributions are coming, and we are working on more about a bunch of features here. And also, we are preparing the multi-platform version of Koin. And all of these are mainly at, I would say that more than 60% is community contribution, which is very interesting. If you need anything, this is the website, insertcoin.io. And if you really enjoy Koin, please spread the word. Thank you very much.